Hello.
No?
Yeah.
Hello,
Hi.
sir.
Okay. So you have a test tomorrow, right, for functions?
Yeah.
Yeah.
If you have doubts, we can ask. And once that is done, we'll do continuity and differentiability questions.
Yeah.
So you can share your questions. We
Yeah.
can discuss
Just
them.
taking a look.
For physics, the portion is electric field and all, right?
Yeah.
Yeah, electrostatic.
Gauss's law has been done.
Yeah.
Okay.
Sir, I'll send the question in the group.
Yeah, yeah. Send it in the group. Okay.
Sir, the sixth question.
1 second. Sixth one is this function R2R, this one, right?
Yeah. Yeah.
Okay. So function R2R be a function defined like this: fx is equal to e power mod x, it is, right?
Right. Yeah.
E power mod x minus e power minus x by e power x plus e power minus x plus e power minus x. Okay. Then it is what? It is injective, not injective, surjective, and whatnot. Okay. So first thing to do is to understand the function in different situations. I want to remove the mod basically, right? So
Right. Yeah.
fx will be e power x minus e power minus x by e power x plus e power minus x for x greater than equal to 0, right? And it
Right.
will
Yeah.
be e power minus x minus e power minus x, right?
Yeah.
Correct. By e power x plus e power minus x for x less than 0, right? So
Yeah.
this becomes 0, right?
Yeah.
Correct. So function is first of all 0 on this side, right?
Yeah.
And this side, notice that it is positive stuff, right?
Right. Right.
All the powers are positive, right? And top part is lesser than denominator, right?
Yeah. Yeah.
So less than 1. So
Okay.
that's
So
it. It
it's
is
not
not
or
surjective for
yeah.
sure, because range will be very limited. No, range is 0 to 1,
Yeah.
Right. Right.
Yeah.
and it is not surjective clearly. And injective is 1 1. Basically, it is clearly not 1 1 because so many values it is becoming 0, right?
Yeah.
So it is not injective also. So whichever option of it you have to mark.
Okay. Yeah.
Correct. Surjective means onto, so range is not equal to codomain, and injective it is not because it is many one function, no, here.
Yeah.
Right.
Yeah.
Yeah.
Okay. So that was the only question in your picture, right?
Yeah. That's the only one here.
Then 41, 43, 45. Okay. Uh, Next one is 41 is consider function gx defined like this. Okay. Wait. Okay. Gx is defined as a polynomial type thing. Okay. Gx multiplied by x to the power 2 to the power 2011 minus 1, right?
Yeah.
Minus 1 is equal to x plus 1, x square plus 1, x power 4 plus 1, so on till x power 2 to the power 2010 plus 1, 2010 plus 1 minus 1. and mod x is not equal to 1, right?
Yeah.
And you have to find out the value of g of 2. Okay, fine. Great. So, okay. There are many things that you can try here. First of all, if I multiply and divide by x minus 1 here, this part immediately sorts itself out, right? I will multiply and divide by x minus 1. Correct?
Right.
So the whole thing becomes very simple because it is becoming a square minus b square throughout, right?
Yeah.
So x square minus 1, x square 4 minus 1. So obviously this will become x 2 power 2010 whole square, right? Minus 1.
Yeah.
Right? By x minus 1 minus 1, right?
Yeah.
So this thing, when you remove the exponent, it becomes 2011 on top, right? Correct? When you brackets are there, you have to multiply exponents.
Yeah.
When you multiply, it will become 2 power 2011, right?
Okay.
So you have this gx into x to the power 2011 minus 1, right? Minus 1, right? Correct? Here, this was in the power, okay? Minus 1 was in the power, no? Okay. Here it is not like that. So,
this one is... okay, yeah.
Like the power had minus 1, no?
Yeah.
I mean, this is slightly different from this, right?
Yeah.
So, minus x plus 1 by x minus 1. If you do the subtraction, what happens, right? You get minus x plus 1. So, it becomes minus x, right? That will work, I think. Let me think 1 second. Let's just do the subtraction. So, it is what? X power 2 power 2011 minus 1 minus x plus 1, right? So this becomes x to the power 2011 minus, okay, it's done, right? You can see it's done, no? X common if you take, right? It's over.
No.
Are you guys getting why it is over? Take x common here, no?
Yeah.
Right. Yeah.
What will be the power here?
2 to the
right?
Yeah.
Right.
Gx is equal to x by x minus
x minus 1. Yeah.
Answer is 2.
2. Yeah.
So basically, the only trick here was multiply and divide by x minus 1. After that, if you follow your normal common sense steps, it will happen. Okay.
Yeah.
Why did I think of that thing? Because obviously, otherwise, how will I simplify, right? There is no chance to do anything here other than some cheap trick. Okay.
Yeah.
41 is that 43. Okay. Great. 43 is the solutions of this equation respectively. Okay. Let 0 is less than alpha, beta, gamma less than pi by 2 are solutions of cos x is equal to x, comma, cos of sin x is equal to x, and the third equation is sin of cos x is equal to x. Correct? Respectively. You have to compare alpha, beta, gamma, which is bigger n, right? So first equation is cos alpha is equal to alpha. The next one is cos of sin beta is equal to beta. And last one is sin of cos of gamma is equal to gamma. Right?
Yeah.
Okay. So we have to compare these values. So we have to compare what value of alpha satisfies this. Cos alpha is alpha, right? So let's look at the graph of cos x. Cos x graph looks like this in 0 to pi by 2, right?
Yeah.
And
Yeah,
y
yeah.
is equal to x graph looks like this.
Right. Right.
And this is cos x, right?
Hmm.
At 0, comma, x is 0, x is pi by 2, comma 0, right?
Hmm.
Right, yeah.
So clearly the intersection will happen at some point somewhere here, no?
Yeah.
Like somewhere in the middle, right?
Middle, yeah.
Yeah.
So if you sort of try to guess when is cos, okay, guessing will not be easy, but yeah, okay, guessing will not be easy. So we'll just imagine that here is our alpha, somewhere here, right?
Yeah.
Right, yeah.
Okay, let's think of this one then. When is cos of sine beta is equal to beta, right? So this means, again, what we have to get is this side, that is cos sine x graph we have to somehow think of.
Yeah.
Cos of sine x, right? Cos of sine x if we can plot and sine of cos x if we can plot, then we'll sort of get what we are on, right?
Yeah.
So, okay, cos of sine x graph. So when you put x is 0, what is the value? 1, right? Right? When you put x is equal to pi by 2, sine pi by 2 is 1, so cos 1. Cos 1 will be cos 57 degree, because 1 radian is almost 57 degree, right? Correct. So cos at x is equal to pi by 2, the value is cos 57 degree, right? Which is less than half, right?
Right.
Which is greater than half, just above half, right?
Yeah.
So just above half at pi by 2, right? So this is your cos 1 basically, right? And what about, is it a constantly decreasing function like this? Let's just check that. So let's take derivatives, right?
Yeah, yeah.
Let's take derivatives. So minus sine x into cos x, right? Now this is positive in this interval and this is positive, this is positive, right? So derivative is negative. So it's a decreasing function, correct?
Yeah.
And y is equal to x graph is 45 degree line like this, right? Correct.
Yeah.
Okay, so we have to compare this somehow. So alpha and beta we have to compare. Alpha and beta. So cos x minus x. Where is this intersection? When is cos x x? Cos 60 is half pi by 3, right? Pi by 3, cos pi by 3 is half, right?
Right, yeah.
And pi by 3 is actually equal to 1 point something, right? Correct.
Yeah.
Pi by 3 is actually equal to 1 point something. So cos pi by 3 is less than pi by 3, right?
Yeah.
Correct.
Yeah.
So the intersection happens way below before this, right? You understand? Near 60 degree, cos x is half, right?
Yeah,
Yeah.
But this value is 1 point something, right?
Right.
So intersection happens way before this, no? Like near 45 degree, right? Cos 45, suppose. You have pi by 4 is 0.75. Cos 45 is 0.7, right? It is close to that, right?
Yeah.
Intersection happens somewhere around that, right?
Yeah.
Actually, it will be some slightly less than pi by 4, so that the angle will be lesser. So this value will reduce, right? And this value will slightly increase, right? You understand?
Yeah.
What am I saying? I'm saying that the intersection point will be before pi by 4.
Yeah.
Correct?
Right.
So of y is equal to x line and cos. My graph is not correct. Okay, my graph is not accurate. So don't get deceived by the graph. But the values, if you think of cos pi by 4 and pi by 4, right? They are very close.
Yeah.
And here the values are close to 60 degree, 57 degree, cos 1 near that, right?
Yeah.
So we know for sure that alpha is less than beta. Now check all the options. Only those options work where alpha is less than beta, right? Now after that we'll see, okay, alpha is less than beta is in everyone. No. And for A and B, right?
A, B, yeah.
Now we have to just get whether gamma is bigger than everything or not, right? Or smaller than everything.
Bigger or smaller?
Correct? So, cool. So, sine of something is equal to this, right? So let's take some angle, sine 60, let's say lambda is pi by 3 again, right? So this side has to be pi by 3, which is 1 point something. And that is impossible because sine will be less, right? It is sine half, right?
Yeah.
Sine half will be almost sine 29 degree, right? Which will be close to half, right? Correct?
Yeah.
And this this value is 1 point something, right? So that
Right,
is clearly not working out. So first of all, you have to restrict lambda to less than 1, right? Because sine cannot give output greater than 1.
Output greater than 1.
Right? So if lambda is less than 1, then angle has to be less than 57 degree, right?
Yeah, yeah.
And if you put angle less than 57 degree, let's check what happens at 45, right? Cos pi by 4, right? This side is almost 3.14 by 4, right? So that is 0.7578, something like that, right? Correct. And this side is 1 by root 2, so 0.7, sine 0.7, right? Correct.
Right. Yeah.
So sine 0.7 will be approximately 7 by 10 into this, right? 7 by 10 into this is 5.7 into 57 7 is what? 350, 399, right? 57
How do
7.
we say that approximately?
What approximately?
Like, how do we approximate sine 0.7?
How do we approximate this one?
Yeah.
Because 1 by root 2 is this one, dude. I know the value of 1 by root 2 almost. Check the value, 1 by 1.414. Do it in a calculator.
No. How will you approximate like sine of 0.7?
Sine of 0.7, because 0.7 is 0.7 radian, no?
Yeah.
How many degrees is that? That is what I'm doing. 1 radian is 57 degrees.
Okay.
So 0.7 radian is how many degrees? That is what I'm calculating in my head. 57 into 7 by 10, no? So
yeah.
350, 7 sevens are 49, 399. So 399 by 10, so 39 degrees, right?
Yeah.
0.7 radian is sine 39 degree here, right?
Yeah.
And we know that sine 45 is 0.7 and sine 36 and all, you need to know the values, right? I think, okay. I mean, you can say that sine is an increasing function. It increases till 90 degree, right? So it will be sort of in the middle of 30 and 45, right?
Yeah.
So half and almost 0.6, let's say, right?
Okay.
Half and 0.7, no? Between 30 and 45.
Yeah.
So this side value is 0.6 and this side value is 0.78, right? Correct. So right now you're not close to solution. You have to reduce the angle further. Okay.
Yeah.
So suppose we reduce the angle further, you'll realize that pi by 6 if I take 30 degree, right? So the right hand side will become pi by 6, 3.14 by 6. So that is how much? 0.52, right?
0.52.
Approximately.
Yeah.
And this side, cos pi by 6 becomes, cos pi by 6 is root 3 by 2, right?
Yeah.
Root 3 by 2 is 0.8, 1.732, 0.86, sine 0.86, right?
Right, yeah.
And this is quite close to, let's take it as 0.9 for the time being, 0.9 radian, right? So that is 9 by 10 of 57 degree, right? Correct.
Yeah.
So 5.7 into 9, so 45, and around 50 degree, right? Correct. Approximately 50 degree.
Yeah.
Sine 50 degree we have to check, right? This side was half, right? And this is sine 50 degree, which is going to be sine 50 degree. So 45 is 0.7 and 60 is 0.86, right? So 50 will be somewhere in the middle, right? Correct.
Yeah.
So somewhere in the middle. So you realize that this is greater than this side, right? Correct?
Yeah. Yeah.
So at pi by 6, our left hand side is greater, correct?
Hmm.
And at
Right.
pi by 4, our right hand side is greater, right?
Yeah.
So the root is between pi by 6 and pi by 4, right?
Right.
Correct. Between
Yeah.
30 and 45 degree will be the root.
Yeah.
Now, our other angles were, one was close to 45, one was close to 60, right?
Right.
So this is the option where gamma is less than alpha beta. You understand?
Yeah.
Yeah.
There will be other ways to do it, but in the exam, you cannot do any other way other than getting values like this. Or checking values and guessing where the root should be. Okay. In the exam, you cannot do anything else. There will be other ways to solve this, which will involve, let me think. Like, properly, if you want to solve it, then sine cos x. Okay, I don't think there's any nice way to solve it. At least it is not striking me immediately. Check the answer once. It should be B.
Yeah, it is.
Right?
Yeah.
Okay. Then 45. 45 is this thing. Okay. Be an even function is saying. Let fx is equal to bracket gif of a square. So this seems like something we have already done. Feels like something we have done, but fine. We'll see. X cube minus 6 fractional part whole square minus 5 fractional part plus 1, right? And into x minus tan x and signum function of x, right? This is an even function for all x belongs to real, okay? Then the sum of all possible values of a, sum of all possible values of a. So basically we have to find the condition that it is an even function everywhere. Possible values of a. Okay. Fine. First of all, signum function is it will split into 3 cases, right? X greater than 0, x equal to 0, and x less than 0, right?
Yeah.
So, okay, so we'll look at that. For now, I'll just write it like this. This bracket x cube minus this bracket x minus, what are the cases? It is minus tan x if x is greater than 0. It is just this minus this if x is equal to 0, but then the whole thing is 0, right?
Yeah.
Right, yeah.
If x is equal to 0, the function is only 0, right? And if x is less than 0, it is this thing minus this thing minus tan x into minus 1, so plus tan x for x less than 0, right?
Yeah.
Correct. This is the definition of the function. Now, we have to ensure that f of x is equal to f of minus x, right?
Yeah.
For all possible values of x.
Yeah.
So, okay. Fine. So, this and this must be equal, right? Somehow. Correct, for it to be even, right?
Yeah.
Yeah.
Correct. Both have to be somehow equal. Or if you put minus x in this, it should become this function.
Yeah.
F of minus x is equal to f of x. This is the condition for even. So what does this mean? This means if I put minus x, I have to use this part of the function, right?
Yeah.
Correct. So if I put minus x here, minus x minus tan x, that should be equal to this, right? Correct?
Minus.
Correct.
Yeah.
I'm putting my f of minus x. So then I have to, because minus x is negative, I have to use this function, right?
Correct.
Yeah.
and f of x is the normal function, the positive part, right?
Yeah.
So this is the equality, right? So tan x cancels, right? And
Right.
you have 2, this comes this side, 2 this thing, and is equal to this goes that side. So 2 this thing, right? Correct? For all values of x, right? For all values of x, this must be equal. So that means x cannot be 0. Okay, how will this be true for all values of x? Only when this bracket and this bracket disappear, right? Like there's no other chance, no? Otherwise x, this will never be equal, no, for all values of x. Are you understanding what I'm saying?
Yeah.
The equation can be true for all values of x only if this doesn't even matter, right?
Right.
Otherwise, 2 cube and all, 2 and all, how will it be same as 3 cube and 3, right?
Yeah.
You understand?
Right.
For all values of x, it can be happening only if this part is becoming 0 and this part is becoming 0, right?
Right.
Yeah.
Okay.
Yeah.
So now our question is basically find possible cases when this and this is 0, right?
Right.
So,
Yeah.
so let's think of that. Okay. So that is easily factorizable, all of it. Like both are factorizable. So this is GIF of A minus 4 multiplied by GIF of A minus 1, right? This will be 0 if and only if either this is 0 or this is 0, right? So
Yeah.
A belongs to 4 to 5 or A belongs to 1 to 2, right?
1 to 2, yeah.
This is the condition for this part. And this factorization will be 6a square minus 6. So 6 common, a minus 1. Okay, I'll just do it. Minus 6, this thing, plus this thing, plus 1. So this is not factorizable, okay? So 3 and 2 is the thing to do. Right? 3 minus 2 plus 1. So 3 this common, and it will get 2 this thing minus 1 minus 1. So the factorization is 2 this thing minus 1 and 3 this thing minus 1, right?
Yeah.
This will be 0 if and only if this thing is half or 1 by 3, right?
Yeah, right.
Fractional part is half or 1 by 3, right?
Yeah.
So what are the possible numbers that can come? 4 plus 4.5. So basically 4 plus half is one number. 4 plus 1 by 3 is one number, right?
Right, yeah.
Then 1 plus half is one number and 1 plus 1 by 3 is one number, right?
Right.
Any other cases are not possible, right? Because then both have to be true simultaneously, no?
Yeah.
You have to have fractional part this and in the numbers like this, right?
Yeah.
So the sum of all possible values will be 4 plus 4 plus 1 plus 1, 10 plus 1, 11 plus 2 by 3, 35 by 3. Is that an option?
Yeah, it's there. Yeah, correct.
So 35 by 3 will be the answer.
Yeah.
You understand? So don't get bothered by this long stuff and all, right? What you have to think, like I didn't even write it, right? I just wrote brackets, this. I was trying to understand when is it going to be even, right?
Yeah.
And I put the condition for even stuff. And f of minus x, how will I understand? F of minus x, how to do? I put it in the third definition, right?
Yeah.
Right, yeah.
And then equated f of minus x and f of x. That gave me tan x cancels, and that gave me this equality, which implies that if you have to make it true for all real x, then the brackets must be 0.
0, yeah.
Yeah.
After that, it is over. Like after that, it is just a matter of doing it a little bit. Okay. So that is this one. Then the next one is Aditya, which question?
The 19th one in the first PDF.
1 second. First PDF 19th. There's no 19th one in the first PDF. Just check 1 second.
The one which has the exercise one.
Okay.
PDF.
19th one.
Yeah.
Okay. F. Okay, this is standard. F0x is x by x plus 1. Fn plus 1 means F0 composition with Fn. Then f of nx is equal to what? You're just doing composition many times, okay? So as soon as you do 2-3 times, you'll get a pattern, okay? Why are you not being able to do this? F1x will be what? F0 composition with F, I'm putting n is 0, right? F0 composition F0 by this rule, right?
Right.
You understand this step, no?
Yeah.
So this is just basically f of x, and I have f of x is this. So f of x by x plus 1. So that becomes x by x plus 1 by x by x plus 1 plus 1, right?
Right.
So that becomes x by x plus 1 by x plus x. So 2x plus 1 by x plus 1. So it becomes x by 2x plus 1. Okay. F1x has come as this, right? You will get F2x by doing what? F0 into F1.
F1, yeah.
And you will get the answer x by 3x plus 1. Do it and check. It will be, the pattern will be x by n plus 1, x plus 1 is f of nx. Just do one more composition, you will get 3x plus 1. Then you can spot the pattern. No? When 2 is here, it is 3 here.
Yeah.
Okay. What else?
In the next one, put out in 3 and 10.
This PDF, nothing else, right? The next one you're talking about exercise 2.
Yeah, exercise 2.
Okay. Given the function f of x such that this is happening, then which of the following is correct? Okay, fine. What is the condition? 2f of x plus f of 1 by x minus 2f of mod of root 2 sine pi x plus 1 by 4. Okay, this is the thing. Then is equal to 4 cos square pi x by 2 plus x cos pi by x. Right? This is the condition that is given. Then what is true? Okay, some f2 plus f half, things like that you want to find out. Okay. Okay, so first thing that I think of here is put x is equal to 2. That will give you 2f2 plus 2f half, right? Minus 2f of root 2 sine pi into 2 plus 1 by 4, right? So basically it is 2 pi plus pi by 4, right?
Yeah.
Is equal to 4 cos square pi by pi plus 2 cos pi by 2, right? So this is sine pi by 4 only. So this is 1 by root 2. So this cancels. It is minus 2f of 1, right? Correct?
Right.
And 2 times f of 2 plus f of half minus 2f of 1 is equal to cos square pi is 4 plus 0. So 4, right? So therefore you are getting f of 2 plus f of half minus f of 1 is equal to 2, right? Correct?
Yeah.
So f of 2 plus f of half is basically 2 plus f of 1, right?
Right.
Now you have to find out f of 1, right? So put x is equal to 1 in this. So let's see what comes. 2f of 1 plus f of 1 minus 2 f of 1 plus 1 by 4, right? That will be equal to 3 pi by 4, right? Pi plus pi by 4. So 3 pi by 4. No, 5 pi by 4 actually. 5 pi by 4, but that doesn't matter. It will be 1 by root 2 because there's a mod, right?
Yeah.
It will still be minus 2f of 1 only, right?
Yeah.
Correct. Is equal to 4 cos square pi by 2. Cos square pi by 2 is 0 plus cos pi is minus 1, right?
Yeah.
So this cancels and you get f of 1 is minus 1.
Okay.
So this is equal to 3, right?
Yeah.
F of 2 plus 1, f of 1 by 2 is equal to 3, right?
Yeah, 3. Yeah.
So answer B is correct because nothing else seems to be working. Answer B is definitely correct, right? Because he's saying f of 1 is minus 1 and he's saying values of f2 and f of half cannot be determined. So maybe right now we know the sum of them, but we don't know individual values, right?
Right.
Correct. Let's see other options also. F of 2 plus f of 1. F of 2 plus f of 1 can we get somehow?
Hello. Yeah, sir, in that question, it'll be 1, right? Because f of 1 came minus 1, so it'll be 2 minus 1.
Oh yeah. What am I doing? So it is 1, right? Yeah. So then A is correct, B is correct.
Yeah.
A is correct, B is correct. So maybe that's all, but I mean, you can check other things also. What is the answer? AB?
ACD.
ACD. Okay.
Yeah.
That means you can find f of 2 and all, okay? Okay. Fine, maybe you can find it. So A is correct. F of 1 is, okay. So basically B is wrong. That means you can find f of 2 and f of half. So how to find it? Okay. So I'll just rub off this part and write down what we know. We know f of 1 is minus 1 by putting x is equal to 1. And we know f of 2 plus f of half is equal to 1. Right? So, okay. So far we have put x is equal to 2 and x is equal to 1 in the equation, right?
Yeah.
And we have gotten f of 1 is minus 1. We have gotten f of 2 plus f of half is equal to 1. These things we have gotten. Let's think of simplifying this a little bit. Okay, how will I get f of 1? Okay, actually C is just the same thing, no? C is saying f of 2 plus f of 1 is equal to f of half, right?
Yeah.
So what is f of 1?
F of 1 is 1.
Minus 1.
Minus 1.
So you're getting f of 2 is equal to 1 plus f of half. No, it is not the same thing. Right?
Will become minus f of 2.
Minus
Yeah. It's not the same.
It is not the same thing. F of 2 plus f of... you're getting f of 2 minus f of half is equal to 1, right?
Yeah,
in C. So let's put minus... Okay, 1 second. If I put minus 1 instead of x is equal to 1, I put x is equal to minus 1. What do I get? 2f of minus 1. Either minus 1 or minus 2. So 2f of minus 1 minus f of minus 1 minus 2 f of minus 1. So minus 3 pi by 4. Again, same thing. This is going to be 2f of 1 and is equal to 4. This is going to be 0. And this is going to be minus cos pi, right? Correct. Yeah. So you're getting, this becomes f of minus 1 minus 2f of 1. 2f of 1 is 2 times minus 1. So plus 2 is equal to minus 1. So plus 1, right? So f of minus 1 is coming out to be minus 1, right? Yeah, and f of 1 is also coming out to be minus 1. right?
Right.
Now it looks like an even function now for us, right?
Right.
It feels
Yeah.
like an even function now. So f of 2 plus f of 1 I have to get somehow f of 2 plus f of 1. Okay, I will just try one more thing. 2 f of minus 2 minus 2 f of minus half, but I don't know f of minus half. Okay, that won't work. Is there something else we can do?
So if it's even, then f of minus half is equal to f of half, right?
F of minus half is equal to f half. Yeah, if it is even, it
Then we
is.
can substitute like one of the equations which you got before, maybe, but it might not work.
If it is even, it will be true. But right now, I'm still guessing that it is
if
even.
it's even.
I'm
There's
still
only one
guessing.
value,
Yeah.
two values there.
Yeah, so I'm not sure right now about that.
Try by putting half.
Huh?
Can we try by putting half, like x is equal to half?
Yeah, we haven't tried that. Yeah, that is a good idea. We can try that. So, oh yeah, that is the best idea. That will work because now you'll get a nice symmetrical type of equation. We have already gotten this, no? We'll get one more equation from there. So it will be 2 f of half plus half f of 2, right? Minus 2 f of, this part becomes half plus 1 by 4, right? So that is 3 by 4, right? So again, it is 1 by root 2 and it becomes 1, right?
1, yeah.
Is equal to 4 cos square pi by 4, cos square pi by 4 plus half cos 2 pi, right?
Yeah.
So cos square pi by 4 will be 1 by 2, 4 into half plus half into 1, right?
1.
So minus 2 into minus 1, right? So you're getting an equation 2 f of half plus half f of 2, right?
Yeah.
Is equal to 2 plus half, right? And plus 2 becomes cancels, right?
Yeah. Yeah.
So you're getting an equation 2 f of
We
half.
get, yeah.
Now you get two equations in two unknowns. It's over.
Yeah.
Half f of 2 is equal to half. No, this is one equation and this is the other equation.
Yeah.
Now you can find f2 and f half from here.
Yeah.
Okay. Yeah. So that was the thing that was missing. X is equal to 1, x is equal to 2, and x is equal to half will give you the answer.
Right, got it.
Okay. Then next one was which one?
The 10th one.
Okay. 10th one. Period of the function f of x is equal to sine cos x by 2 plus cos sine x is equal to what? Period of this function. So obviously there are, if you find the fundamental period, then any multiple of that will work, right?
Yeah, yeah.
So basically find the smallest period and after that multiples of that will give you the multiple correct here, right?
Is the only method putting x as x plus 3 and doing it in this fashion?
No,
because with that I got
what? With that you got
because
what?
doing that I got 4 pi as 3, so I got the answer A and B, but I just wanted to confirm if that is the only method because I couldn't think of anything else. Like I wasn't
You
getting
did this.
Yeah.
And by simplifying, you're getting t as 4 pi.
Yeah, but I just wanted to ask if there is any other way we can do this because I wasn't getting it in any
Individually,
other way.
you can think of these functions individually, no? What is the period of this function? Cos will repeat after 2 pi, right?
2 pi, yeah.
And then sine will obviously repeat after 2 pi.
Yeah.
Right? Is there any smaller period possible here? You should think of a smaller period also because it's a complicated function. So sine graph is like this, correct?
Yeah.
And sine is going from 0 to 0 over 1, 0 to pi, and cos of that. See, sin x values will be between -1 to 1, right? Right? So basically the angles to the cos are only between minus almost 57 degree to 57 degree, right?
Yeah, and
Right.
the value will.
So the values of the cos that come out from here will only be between, okay, that doesn't influence anything because cos values there will be minus 60 to plus 60, around that will be minus half to half, right? Something like this. Like something like this, right?
Right.
This is your cos function, but after that, again, sine will go from -1 to 1. Okay, it's a graph is somewhat like this, no?
Yeah.
Graph is somewhat like this, but it is stretched out over the entire x variation, right? Okay, I understand. So, okay. So the graph of this function is going to be like this. See, the entire variation of sine from -1 to 1, over that variation, cos is going to go minus half to half, almost half to half, right? You understand? It is always positive. It's like this. This is 0 to 2 pi. Okay. And then again it repeats, right? Is everyone understanding why I'm saying its graph is like this? It is slightly above half.
Yeah.
Or below half, whatever. But going up to 1 and going like this, right? Over the 2 pi variation of the sine, right?
Yeah.
So period of this is definitely 2 pi. And if you think about this, period of this is 4 pi, no? Correct?
Yeah.
And again, the graph is similar. The cos values will give outputs of -1 to 1, right? But this time sine will be from negative to something, right? It will be repeating like this. You understand?
Yeah.
Cos will give outputs of -1 to 1. So the angles to the input to the sine is from -60 to 60 approximately, right?
Right.
And sine will be like this, right? -√3/2 to √3/2, right? And this will be stretched out over the entire 4 pi region, right?
4 pi, yeah.
You understand what I'm saying? All of you.
Yeah.
So the graph of sine cos x/2 should look roughly like this. I mean, it will be very bad drawing, but whatever. It will be roughly like this. 0, 4 pi is here. And the graph will be something like this, right? Okay, not correct, but something like this. Some symmetrical graph with odd function type of graph, but from over this range, right?
Yeah.
And then it will repeat again, right?
Yeah.
So because sine is the final function that decides the values, right?
Right.
Correct. So this period is 4 pi, this period is 2 pi. So LCM of these two is what? 4 pi.
Right.
So this is the other method. You don't have to do all of that calculation. You can just find period of this, LCM of them will be the combined fundamental period, and then multiples of that will be the answer. Right?
Right.
Yeah.
Okay. Next one is which one?
In the next PDF, the first one.
First one. Okay.
Yeah.
F of x plus f of y is equal to f of x plus y for all xy belongs to real. F of 1 is equal to 1. Find the value of f of 10 multiplied by, find the value of this. Okay, f of 10 by 5. That's it. I think the other thing is a statement. F of x is not constant. Right? You have to find the value of f of 10 by 5.
Right.
Okay. Okay, fine. So, fine. In these types of, these are functional equations. Generally, they are the most annoying questions because there is no method. There is just tricks. Okay. So here we have to think of some tricks now. So let's say put y is equal to x, right? So f of x plus f of x, right, is equal to f of x plus x, right? Correct.
Yeah.
So f of x is x. So answer is 2. Is the answer 2? Check once. Oh, if that is the case, dude, yeah, it's sad for you
Oh
guys.
yeah. Right.
It is 2 steps, dude. How did I get it? Put y is equal to x. This input is giving same output, right?
Yeah.
Right.
Yeah.
So it's identity function.
Oh. Okay.
What else, right? How can some arbitrary input give the same output?
Yeah.
Right.
So actually, this is an easy one. Normally, questions are not so easy, okay? When functional equations are there, then it is going to be, generally these are asked in Olympiads and much harder ones are asked. So, but this was a very easy one. Okay. Next one.
Just a second.
Okay. Answer is 0, dude. Second one. A function that is odd and even simultaneously is a constant function.
I didn't say the second one. I told 1 second.
Oh.
Yeah. In exercise 4B, not in 4A, you can skip the third PDF.
This PDF is done.
Yeah, this PDF is done. The view PDF 5.
Okay.
And that exercise.
Which one?
Exercise 4B, I have it out in the 6th one.
Okay. Okay. 6th one. F of x is equal to x square minus x by x square plus 2x, where x is not equal to 0 and minus 2. Then you have to do d by dx of f of inverse of x, right?
Yeah.
Correct. So basically, inverse function's derivative is being asked, right? Let's call the inverse function g. G is equal to f inverse x, right? So basically, what is being asked? G dash x, right?
Yeah.
Right.
Okay. Generally, many times this has been asked in IIT. Generally, whenever there are inverse functions and the normal function is complicated, the thing is you don't have to find the inverse to find the derivative. Okay. You have to use your understanding of functions to get the derivative. So if f and g are inverse of each other, then what is true? F of g of x should be equal to x and g of f of x is equal to x, right?
Right, yeah.
This has to be true. Now, if I do differentiation by chain rule here, right? Chain rule. So I will get f dash g of x, g dash x is equal to 1, right?
Yeah.
And you'll get g dash f of x, f dash x is equal to 1, right?
Yeah.
Right, yeah.
Correct. So g dash x, I can say, is equal to 1 by f dash g of x, right? Correct.
Right, yeah.
Now, f dash x is easy to find, right?
Yeah.
But gfx I will have to input there, so it will be slightly annoying here. Okay. Okay, I think gfx is easy to find here. Actually, f of x is just simply x into x minus 1 by x into x plus 2, right?
Yeah.
So it is x minus 1 by x plus 2 is f of x. So it is very easy to find inverse here. Actually, we don't need all this also. So y is equal to this. So y into x plus 2 into y is equal to x plus 1. Solve for x in terms of y. So x, y minus
So it's
1.
x minus 1.
Oh, yeah.
Yeah.
So it becomes yx plus 2y is equal to x minus 1. So y into x minus 1 is equal to minus 1 minus 2y, right? So
Yeah.
y is... okay, I have to solve for x in... I have to solve for x in terms of y. X minus 1. So 2y plus 1 is equal to x into 1 minus y, right?
Yeah.
X is equal to 2y plus 1 by 1 minus y. So the inverse function will be replace x and y here, right? 2x plus 1 by 1 minus x is gx, right?
Yeah.
Gx,
And
yeah.
take the derivative of that. If I do derivative, it will be on top, it will be 2 into 1 minus x minus 2x plus 1 into minus 1, right? By 1 minus x whole square, right?
Yeah.
So it will be 2 minus 2x minus plus 2x, right? Minus so plus 1, right?
Plus 1.
So 3 by 1 minus x whole square.
Yeah.
So actually this question was not about this thing. This thing is applicable when the inverse is not almost impossible to find. There are situations where inverse will not be so easy to find, okay?
Right.
This step you will not be able to do for some functions. And there will be questions in the exercise. For example, 8th one. 8th one, you cannot find inverse.
Yeah.
Okay. So, and there are other questions which are slightly harder, which are not JEE mains questions, which you will, okay, I'll show you 1 second. If they have given advanced questions, they have not given. Oh.
It's the next, will be there in the next PDF.
Yeah, so there are several questions like that, but yeah, this one was easy because you can find the inverse. Okay. Then which one?
22.
Okay. Okay. 22 for x belongs to real minus 0 and 1. You have to remove 0 and 1. You have functions f1x is equal to 1 by x, f2x is equal to 1 minus x, and f3x is equal to 1 by 1 minus x. In these functions, if a function jx satisfies, okay, this part is not very clear to me. f2o f1. J is a function which satisfies f2 composition with j composition with f1, if I am understanding correctly this thing. X is equal to f3x, right? Correct?
Yeah.
So it's just f2 j f1x is equal to f3x, right? Correct. Okay. So fine. We know f1, we know f2, we know f3. We have to find j, right?
Yeah.
So let's do f2 inverse here first of all, and write f2 inverse here, right? Correct.
Yeah.
That will at least cancel this one. Correct.
Right.
Yeah.
Right.
So j of f1x is equal to this, right?
Yeah.
And instead of x, if I put f inverse f1 inverse x, right? Instead of x, I'm putting f1 inverse x.
Right. Yeah.
So you will get f1 and f1 inverse will cancel. So you get j of x, right?
Yeah. J of x.
So basically j of x will be equal to f2 inverse f3 f1 inverse x, right?
Yeah.
Now find the inverses of each of them, right? f1 So this is y is equal to 1 by x. So x is equal to 1 by y. So x is equal to 1 by y, and replacing it is going to be 1 by x only, right?
Yeah.
Okay, that doesn't make sense. X should be the inverse of this, no? Inverse of f 1 by x should be x, no? If one function does reciprocal, the other function should also do reciprocal. Yeah. So if I do f of g of x, where g of x is also 1 by x, right? So f of 1 by x will be x. Okay, this is correct.
Yeah.
Right? So 1 by x is the inverse of f1, right?
Yeah.
Yeah.
So this function is becoming 1 by x, right? So f3 of 1 by x is what? f3 of 1 by x becomes 1 by 1 minus 1 by x, right?
Yeah.
So that becomes x minus 1, x by x minus 1, right?
X minus 1.
So now you have to do f2 inverse x by x minus 1, right? Now first find f2 inverse, right? So y is equal to 1 minus x. So x
Same
is equal to
thing
1
again.
minus y. So inverse is 1 minus x only,
1
right?
minus x, yeah.
Yeah.
So inverse of f2 is 1 minus x. So 1 minus x by x minus 1, right? So
Yeah.
x minus 1 minus x, so minus 1 by x minus 1. Or basically 1 by 1 minus x is my answer.
Right, got it.
Which is equal to f3 actually.
Yeah.
Right? So
Yeah.
how did I isolate j? I saw this and I did first outside f2 inverse to cancel this. So both sides have to do that. Then I got this. I have to somehow get j of x, not j of f1x, right? So inside for x, I will substitute f1 inverse x, right? You understand?
Yeah.
So finally I got this thing. And this thing, if I calculate, I get the answer. Okay, next, tell me.
Sir, can you just explain implicit and explicit functions?
Implicit function is a situation like this too. We have seen equations of conic sections like this, right?
Yeah.
So right now you cannot solve, it might be hard to solve for y in terms of x. Like right now it is possible because I can make a quadratic and solve, right?
Yeah.
Actually here x and y are two variables that are connected.
Yeah.
Two variables that depend on each other, right?
Right.
So if you want to say that y is a function of x, right now it is not clear what is the exact definition of y in terms of only x, right?
Yeah.
Because it's mixed up like this. You can get complicated situations like this. 2x log y plus e power x plus pi is equal to... Now it's impossible to solve.
Right.
Now it's impossible to solve. At least here you could solve as a quadratic and get it in terms of x, right? But here it is not possible because it's not even a polynomial, right? Because of this log y.
Yeah.
So you can't solve it. So this is called an implicit definition of y in terms of x. Implicit definition. Basically, it is hidden inside. It's not explicit.
Okay.
Y as a function of x. So you're not able to get a function of x directly, but you can still somehow get dy by dx here. Rate of change of y with respect to x, because I can term by term differentiate everything.
Yeah.
Thinking of y as a function of x. So I can do 2x plus 2y dy by dx plus whatever, keep doing that, right? Collect all the dy by dx terms together, take common and get dy by dx, right?
Yeah.
So normal function that you have so far seen are explicit. This type of weird situations where the y is not clear what it is exactly, that is implicit.
Okay. Yeah.
Okay, what is the next doubt here in this one?
The next PDF.
After 5, there is more, okay?
No, like...
View PDF 6.
View PDF 4, I have a doubt in.
View PDF 4.
Yeah.
Which one?
For me, it's below view PDF 5. It has function as its heading.
It's the theory.
Like
Yeah, yeah.
yeah, it has unit exercise and the beginner boxes. I have a doubt on page number 39 of the PDF.
Okay.
The beginner box 10, third question.
Okay. Function R2R, this one, no, satisfies. Function R2R satisfies the condition x square f of x plus f of 1 minus x, okay, is equal to 2x minus x power 4, right? Correct?
Yeah.
Okay, this is a standard thing. This is a standard trick. Okay, so right now, think of this and this as your two unknowns. Okay,
Right.
correct? So these are two unknowns. I have to find one of them, right?
Right.
So instead of x, if I put 1 minus x now in every place, right? So it will get what? 1 minus x whole square, f of 1 minus x plus f of 1 minus 1 minus x, right?
Yeah.
Is equal to 2 into 1 minus x minus 1 minus x whole power 4, right? Now you'll see that this is f of x, right?
Yeah.
And this is f of 1 minus x. And this is a new equation using the same two variables, right? Correct?
Yeah, yeah.
So now think of these as variables. I will call it A and B. And I'll call it A. This is B. And this is A, right?
Yeah.
So just solve for A, right? You understand? In this equation, I can take 1 minus x common here and it becomes 2 minus 1 minus x whole cube. And here I can write 1 minus x whole square f of 1 minus x plus f of x. So, okay, that didn't help much. You have to just solve for fx, right?
Variables, yeah.
So what I will do is I will multiply both the equation, this first equation by 1 minus x whole square. Okay. And that will, and subtract, so cancel this one, right?
Yeah.
Right?
Yeah.
You understand? It will happen then. So you will get 1 minus x whole square into x square minus 1 into fx, right?
Yeah.
Is equal to this thing minus this thing, right?
Right.
So 1 minus x whole square multiplied by 2x minus x power 4 minus 2 into 1 minus x plus 1 minus x whole power 4, right? Simplification might be annoying, but it is over. Question is done.
Yeah.
Right.
You are understanding what I'm saying, no?
Yeah.
Yeah.
This and this were two different things, but the pattern is such that you can put a substitution and replace it, right?
So we could have replaced it with like 0, 1, those kind of values also, right?
But that doesn't give you f of x. That gives you particular values of f of, right?
Yeah.
Okay.
You understand? If the question was asking f of 2, then you are right. Then you should do some values, right?
Yeah.
But if the question is asking the function itself, then you don't have to put particular values, right?
Right.
Okay.
You have to solve for f of x.
Yeah.
So think of these type of functional equations as normal linear equations with some unknowns. You have this as an unknown, this as an unknown. You have to find one of them. So you need another equation with having same two variables. If you do some weird transformation like x is equal to x plus 2 or something, you will introduce new variables.
Yeah.
So do transformations that don't introduce new variables and keep the same number of variables. So if you can do that, then it's over.
Yeah.
Okay. What is next? After this, Rishi also has sent something, no? 29 and 31.
Yeah, 2 questions.
Okay, let's do 29. F of R to R, f of x plus y is equal to f of x plus f of y. Okay. For all xy belong to real. Correct. So f of 1 is 7. You have to find what? Summation of 1 to n f of r, right?
Yeah.
And f of r is what? So now this is a very famous equation. This is Cauchy's functional equation. And you can prove by induction that the solution to this equation would be the linear function f of x is equal to kx, right? See? F of x plus y will be what? K of x plus y, right? Which is k of x plus k of y, right?
Right.
So this is a solution to this functional equation. So f of 1 is 7 gives f k is equal to 7, right?
Mm-hmm.
Correct?
Yeah.
Yeah.
So basically your function is basically 7x. Now this summation is very easy because it becomes 7 into 1 plus 7 into 2 plus so on till 7 into n, right?
And yeah.
7 into n plus 1 by 2, right?
Okay. Yeah.
That should be your answer. So some of these functional equations, you need to be able to look at the function and guess what kind of property has, what kind of equation will satisfy this, right? What function will satisfy. So for example, this is a clear-cut linear function which will satisfy this property, right? If you had something like this, f of x into y is equal to f of x plus f of y, right? So a logarithmic function satisfies this, no?
Yeah.
So log of, let's say, c log x is my function, then c log xy will be equal to c log x plus c log y, right?
Right.
So if you have a situation like this, f of x, I mean, there will be a corresponding situation for exponential functions, right? This is an exponential function. No, this is not exponential. But there are similar situations, okay? So you have to look at the question, and sometimes it is easy to just know that, oh, obviously linear will satisfy here, right? So in your Allen book, at the end, there will be a table with some functional equations and their possible answers. In golden key points or something, there will be some table somewhere. You have to look at it.
Yeah.
Like, I'm sure it is there. Wait. Let me see.
It's not there. But our teacher gave it to us.
There will be some list of some typical functional equations and answers in those cases.
Yeah,
okay.
So actually gave.
So don't memorize them, but just understand why those are working.
Yeah.
You understand? Like here, I knew that it will be linear, right? So you don't need to do much here. So don't try to mug it up. Just check those functions and see if it works there. Right?
Yeah.
Okay. Then next one is 31. Okay, a real valued function fx satisfies this equation, functional equation. F of x minus y is equal to f of x, f of y minus f of a minus x, f of a plus y, right? Where a is a given constant. A is a constant. Okay, this is obvious. This is cos function. And a is pi by 2. I feel like. See? Minus cos pi by 2 minus x is sin x. And pi by 2 plus x is what? Cos pi by 2 plus x. Is sin y, okay, slight issue. Oh, it is fine only, no? Are you seeing what I'm saying?
Yeah.
The function is, I think, cos x. A is pi by 2. Fx is cos x. And Now, if that is true, f of 0 is 1, see it fits. F of 2 into pi by 2 minus x is f of pi minus x is minus cos x, is minus fx. Answer is C. Ke?
Yeah, C.
Yeah.
So why was I able to guess it? Because I know my cos formula, no? It looks like that, no? This into this minus, like now that you see it, it's obvious, but in the beginning also it was obvious. Because,
Right.
I mean, I saw f of 0 is equal to 1, right? F of 0 is equal to 1 gives you a hint that maybe it is cos only. Cos formula has cos minus sin, no? So that is what I was thinking.
Yeah.
Okay. What else? Tell me.
Or in the last PDF which we were doing, in that
View
on
PDF
page number
6. 6 or
4.
which one? 4.
Yeah.
Page
in
number?
that on page 51.
51.
Yeah, it's the unit exercise part. I have it out on 38 and 56.
Okay. 38 and?
56.
Okay. 38. F of r to r. F of x is equal to root over x square plus 1 minus 3x by root over x square plus 1 plus x. You have to find range of this, right? Okay.
Right.
First of all, realize that.
Split it.
Kya?
We could split it, right?
Yeah. You can split it. It is 1 minus 4x by. Right?
Yeah.
Plus x minus 4x, right?
Yeah.
So clearly, okay. It could be greater than 1 if x is negative, right?
Right, yeah.
Okay. Fine. Range of this we want to find. So if I know maxima minima of this, then I will be able to say no range. Right. Okay, first I will do x tends to infinity. What happens? I will take the limit of this thing, right? So I will divide by 4 x, and it just becomes root over 1 plus 1 by x square plus 1, right? So x tends to infinity. This will be tending to 1 minus 4 by 1 plus 1, 2, right? Correct?
Yeah, so minus 1.
As x tends to infinity, f of x tends to minus 1, right?
Right.
X tends to minus infinity also, it tends to same value, right?
Correct.
Yeah.
Correct.
Yeah.
However, we need to know what else is happening here. When x is 0, function is 1, right? F of x is 1. Correct?
Yeah.
So is it going to be, okay, when x is negative, there is a chance that it can be greater than 1. So that is what we have to figure out now, right? So the lowest possible value of this, right? Minima of this I want to find, because then minima will become plus 1 plus something, right?
Yeah. Yeah.
So, okay, minima of this. Minima of this happens when, okay. Yeah, I will do calculus. I will do derivatives then, because immediately it's not obvious what to do. If I do derivatives, I'll get 4 into root over x square plus 1 plus x minus 4x into derivative of this will be 1 by 2 root x square plus 1 into 2x plus 1, right? By this thing square, right? Now, this thing has to be 0. Derivative has to be 0 for maximum minimum of this function, right?
Yeah.
Yeah.
So this cancels. This is x plus this thing. So you have 4 into this bracket minus 4x into x plus this thing is the same bracket, right? Divided by root over x square plus 1, right? So 4 into same bracket is coming out and it is becoming 1 minus x by root over x square plus 1, right?
Yeah.
Right.
By
Yeah.
this square, right?
Square, yeah.
And this bracket is actually, can the bracket be 0? Maybe. So let's check. Root over x square plus 1 plus x.
You can cancel the brackets one, right? Because both the brackets are
Bracket cannot be 0 then, right? Because then
they get cancelled.
then denominator is there, no? It's in the denominator,
the bracket
right?
cannot be.
Bracket cannot be 0. So we
Only
don't have to worry.
one.
So this has to be 0, right?
Hmm,
So
yeah.
1 is equal to x by root over x square plus 1. So x square plus 1 is equal to, okay, that doesn't happen. That doesn't happen, right? That cannot, obviously it cannot be 0. So then the function, that is great actually. It cannot be 0, right? And this is less than 1, right?
Yeah.
So this is positive always, right? Correct?
Right.
The derivative is positive always. That means function is increasing, right? This function is an increasing function. So as x tends to infinity, right? The value is the maximum, right?
Right.
Minima, right?
No, it is, this function is increasing.
Yeah.
So this value is maximum, but the function becomes minimum, right?
Yeah. Right.
So it is minus 1 that we got is actually a minimum of the overall thing, right?
Yeah.
So the answers will start from minus 1, okay? And there is only one option like that, so I don't need to worry about it. I will mark the answer at this stage, B.
Yeah.
But let's think about the other case. It is increasing. So when x is minus infinity, right? Minus infinity, this function is going to be what? Okay, so 0 is the, why is it always increasing, bro? Slight confusion here, but answer is B, yeah?
Yeah, it's B.
I feel like it is wrong though. How will it ever?
We simplified it to 1 minus 4 by root 1 plus 1 by x square, right? So even if x is negative or positive, it's the same thing because it's x square.
I know, that is why it's a problem. I mean, this function doesn't seem to be a, okay, this is definitely an increasing function because as x is increased, this value is reduced. So this root is becoming, it's a weird thing. I don't think the answer is right here. I feel like something is wrong in the answer. How will the function ever attain minus infinity? Oh, plus infinity. When your value of x is minus infinity, what is the value of this function? It is, you can divide by x and you'll get 1 plus 1 by x square minus 3 by 1 plus 1 by x square plus 1, right? So that limit is tending to minus 1 plus 1 by x square, 1 minus 3. So minus 2 by 1 plus 1. Minus 1 it is tending to, right? Which we got already.
Right, yeah.
And as x tends to infinity, also it is tending to same thing. So where is infinity coming? You understand?
Yeah.
Right.
Where will it rise up? Like it will not. I think answer is wrong. Actually, the best way to do it is to plot this on Desmos. Okay, plot it.
Yeah.
Just check the graph of this. You will get the idea. But I feel like something is wrong here. What is the next one?
56.
Okay. F of x plus ay, comma, x minus ay, okay, is equal to axy. Then f of xy is equal to what? Okay. X plus ay, comma, x minus ay. Okay, so you have to get an identity where this and this combine together to give axy, right? So it is obvious it will be x plus ay whole square minus x minus ay whole square by 4, right? See, that will cancel every square term and give 4axy, right?
Yeah.
So my function f of xy will be what? X square minus y square by 4.
So just by observation.
Yeah. The inputs are being taken and same inputs are coming here, no? Are you understanding?
Yeah.
I have used the inputs to write it in terms of inputs, no?
Yeah.
So now check whichever option is giving this. So first A is correct. B is also correct. C is correct. C is correct. Right?
Yeah.
A and C are the answers.
Yeah.
So these functional equations type of things, no, they are mostly tricks. So it depends on how much experience you have and whether you can spot these things. Like this is just checking whether can we get this in terms of this, right? That's all. Which is the next one?
I don't have any other doubts.
Okay. Fine. Nobody has any other doubts?
That's it, sir.
Okay, so all of you have basically done all the questions in Allen, right?
Yeah.
I haven't finished all the questions.
Yeah.
We didn't finish the chapter like fully yet. Today we will finish it.
Okay. But fine, if you have gone through the unit exercise and all, then it should be fine. Test should be fine. Make sure that you go through your unit exercise before the test. Okay?
Yeah. Okay, sir.
Yeah.
Yeah, that's all then. Okay. We'll do a physics class later this week too. We'll do a couple of physics classes.
That question, it is actually going from -1 to infinity.
You put the graph?
Yeah, I plotted it. It is.
Which point is becoming infinity?
I think it's -1.
At -1?
At -1.
Wait, let me see. It was question number something, no? 38, yeah?
38.
Yeah, 38.
1 second. Then maybe I'm missing something. -1. Just hold on 1 second. I'm getting a call. This was exercise number, which one? 4.
This is unit exercise.
It's unit exercise.
Okay. At -1, so at -1, it is becoming √2 plus 3 by √2. How is it becoming infinity, dude? This is the value that is coming, no? at near -1? Maybe you have mistakenly typed something wrong in Desmos or something. You understand?
One sec, let me just send a picture.
Yeah, it's showing it's getting infinity.
Where is it showing infinity? Which point? Near?
It's close to -1 itself. No, a
It's a
little
very steep graph.
close to -1.
That doesn't seem very possible, but I don't know what is happening. √2 - 1 is a small value, but it is not going to be.
No, it's not -1. It's -2 probably. Or yes, no, it's not even -2.
So basically, it will be infinity when this part is 0, no denominator, right?
Yeah.
This denominator, √x² + 1 is equal to -x. When is it going to happen? Never. Right? Only for imaginary numbers it will happen, no? You understand? How will the denominator be 0? It's not possible to be 0. X is equal to -√x² + 1. Is it possible to be?
Yeah, maybe tending to 0.
When x is something negative. Oh, it is. No, it is not possible. Not in real numbers, dude. You understand? This is impossible, no, in real numbers. Okay, I'll think about it, but it doesn't seem possible to be infinity.
Okay.
I mean, are you guys being able to see why I'm saying it's not possible?
Yeah.
Denominator is not disappearing ever. If you take -x also, like the inside the root thing is bigger than the -x always. Right? So it might become small value, but it will never be 0.
Yeah.
So the thing will always be finite, never be infinite. Right?
Yeah.
But it could be steep. It could be steep. That is possible. Okay.
Right.
Okay. I'll see you guys later then. Bye.